Alright, so in this video I want to show once for all that the controller does not generate the EMI, and I have it actually connected here. You can see the levels it gets are very low, and this is after you did the ground thing, right? So we don't have floating ground, and this is the data cable. I have to go really close, it doesn't pick up anything. Now on the servo side, the motor obviously has a little bit of noise. Right now it's on but not activated, so you can see it has a little bit noise there. The power side, the power cables, you can see the noise there. You can see it not only it has the power, put the light on, not only has the noise from the power line, but also has the electromagnetic harmful. See that? I'm gonna move it away so you can see the difference. They say safe, you go there, it says harmful, both of them. Now the difference here, for example, it may pick up something, but it doesn't have any electromagnetic noise around. It doesn't even register anything. Even the power line, that's the power line after the filter, it doesn't get much electromagnetic noise either. So the power that goes to the servo, that is dirty, you can see here it electromagnetic, it's on harmful side, the noise there. So I'm just going to leave it here. So I'm going to turn off the servo. I'm just going to disable it. You can see as soon as I disable the servo, it's on, it's all activated. Just disable the servo from being powered. Alright, so it just measures essentially a little bit of dirty line without the too much noise. Now if I activate again, you'll see right away that it goes up again. At the other side of the line filter, which is on the power side, let me get this all settled down. Come on. Okay, all right. You can see here on the power side, it has a normal below 400 value. Okay. But of course here there's nothing on the controller, even if all is active. To show you another example, let me turn this off. So I'm gonna use this. Alright, okay. Now again, there's nothing detected here. Cables, anything here either. Even the motor is actually active, on. Right, there's some voltage detected there. Now I'm just gonna leave it right on the servos and try to move the servo to see what will happen just with the buttons. That's what's generating actually lots of the electromagnetic noise when it's moving. Okay, and the same with this. It's hard to get right on the spot. But anyway, you get the idea. So maybe here. doesn't change much that. On the power side, let's see here. No, it doesn't change much there. So actually the other one, I think it's gonna show better how this is doing. Alright, so I have it's active. So I'm gonna do some movement. See, it's changing the value, but doesn't change much. The actual motor has less actually. It's activating the other tester because a lot, because it's more sensitive to switching noises. But this one actually, you can measure the noisy environment right on it. So let me power it off from here, from the e-stop. Okay, so there is no signal to enable the motor, and then you can see right where I had before, it's just the normal power you get from the network. Let me release this and you'll see the change. Immediately goes up. So this is why we need to have a line filter to block all the bad EMI from the servo drives at the motor. Essentially the motor is generating some noisy electrical which gets feedback back to the power line. So to prevent that, we'll have to use line filter, and of course it will have to be on the same circuit and have common ground, so you don't have any ground loops floating around. I'm gonna see that again here. If I disconnect, for example, the direct ground I have, and remember this is without ground, that connector, so it's essentially right now floating. You can see it there. It doesn't float that much because it has the connector, some grounding from this device there. For example, that's another thing. It's even worse because now, for example, there's nothing connected. It's floating even worse. But still, this side is kind of grounded. This is still not good grounded. It's so the point is you have to use ground points to single points as possible, so you don't have ground loops or floating grounds. A great example of floating ground would be this floating ground loop. Anyway, just a joke, but you get the idea. You just have to take care of the wiring a bit and make sure that nothing is floating, and line filters are used in the correct parts of the circuit. And this way you could use USB devices that are not sensitive, and of course make sure to keep all the noisy wires away from data cable. So even a few inches can make a difference. So if you can put further away stuff that could be for USB or powering small peripherals away from the servo motor cables, head power and everything, will definitely make a difference. Anyway, that's all for now. Thanks for watching.